See if YouTube is going to be YouTube again, like it was last week. All right, everybody, here we are. Hope everybody can see me. I don't know if you can. Not seeing my face in the thingamabobber, but is she sleeping? Dwight says, am I sleeping? All right, let's, all right, now I'm hearing myself.
You hearing yourself?
I'm hearing myself. And I mute myself so I don't hear myself. Let's see. Can they see me?
Hey, Schuylkill River Valley.
He says he can
John.
see me. Oh, all right. They can see us good. All right. I was
Does
worried.
everybody hear us okay? You hearing an echo?
I don't hear an echo. Does anybody hear an echo? All right. Well, as you guys can see tonight, I have David from DBTech with me, and he's going to give us a little insight into some sensors for our layouts. I'm very, very excited. Something I'm really wanting to learn about, and Lord knows I have a lot to learn. So before we get started, oh, and before I forget, the person that won the cookie, I already forgot who won the cookie. Oh, I gotta write it down because they were here last night at like 10:45. Oh, where did it go? Well, I don't remember, and I wrote it down. Len McCurdy. Len McCurdy won the cookie. So, Len, you won a cookie. Merry Christmas. Oh my goodness. And I'm glad to hear you're safe and sound back from your trip to Antarctica. It looked very chilly, but like a lot of fun. So, all right, guys. So far tonight we have joining us CNEI John. Hi, John. Just saw you the other day on live with Steve Childers. And we have Mike from Deep Run Railroad. We got JD from Grandpa Rails, Eddie or Edward from Happy Valley Hobbies, Joe Rader, Black Rock Central Railroad, John Beniki, Dwight from the Curly Express, or Tuna Head as he's affectionately been called, Lynn McCurdy from the HD MMRC, myself, PK and W Model Works, Ray Bobel, Ron Moen, Santa Fe Bob, John, number 2 from the Schuylkill River Valley, Scott Johnson, my one and only, Sidetrack 77, Tim D, and 3 Dubs from the Wigwag Workshop. Welcome, welcome, welcome. Thank you guys for joining us. And I think my YouTube's actually working this evening. Hey, just a side note, if any of you noticed that your YouTube is running slower than normal, apparently there's a little snafu between AdBlock and YouTube. And if you have any AdBlock on your computer, YouTube doesn't want to run properly. It took me a few days to get that figured out. So just a FYI. All right, so I'm going to slide this over. And nothing sliding. All right, I did it. I did it. All right, so David, what have you got for us tonight?
Yes. We're going to talk about different types of track sensors. Sorry, I'm still hearing a little bit of an echo, so I stop every once in a while.
That's okay.
But yeah, sensors for doing different kinds of animations or other functions on your railroads. In other words, when your train goes past a certain point, it'll do something. Turn on the light, hit a turnout, activate a crossing gate.
Can you use it for what's the thing, like when you're trained, like if you want to drop off a car or something like that, can you use it for something like that too, or is that something completely out of the wheelhouse for that?
You can set it up to stop at that point. To actually dump a car, it would work differently. You would have to have a separate operation.
Okay.
Some cars have like something comes up from the bottom to push the car and dump it. Trying to think, like the Lionel has an action track. So you press a button to activate a magnet and that dumps it.
Nice.
So there's different things like that. I have a Tyco log dump, and that's like a separate accessory where you press a button and it causes the car to dump. So, do you have my document camera?
See if I can make it bigger.
If you want to make that big and the other two small.
Yeah, that's what I'm trying to do, but wrong one. I drag it over here. There you go. It did it.
All right. So yeah, that's basically what I just talked about. Let me turn down the volume. Okay. Yeah, I am hearing myself back. But anyhow, so that's different types of uses for a train sensor. So I guess the first one we'll talk about is a simple one, reed switch. And I'm just going to give you an introduction on like what they are and how they work. And then after what you do with them, there's, you know, countless amounts of things you can do with them. I remember at the choo-choo barn there in Lancaster, and the train, when it went past a certain part, would operate a merry-go-round.
Oh, wow.
The whole circus scene.
Oh.
Yeah, that was interesting. And I remember the one that had the fire truck that would come out at certain points, run around.
That's pretty cool.
Yeah.
So IR, is that infrared? Am I just...
Yeah, that's right.
Okay.
Infrared. Just the same. I forgot to grab a like a TV remote.
Okay. Oh,
So,
same idea.
Same idea.
Okay.
Yeah. Let me see something here. I have a remote. I don't know if it has batteries in it. Let me check something out real quick.
Okay. Sparky.
See how good these are. There you go.
Oh, I can see it. Okay.
So the camera can see it, but of course, if you look at your remote control, you can't see it. But yeah, you press your remote control for your TV, and
So
that's the same thing.
That piece would what go like in the track? I think from one of your videos you had it like in the track just below, so the train doesn't run into it, and then when it goes over it, what breaks the beam of light or something, and then that's how it works.
Yes, that's how that video worked. How that operation worked in that video.
Okay.
It's not in the track; it's on each sides of the track.
Okay.
So, yeah, that operates different, and I'll show you that one.
Okay. What's a reed switch?
Yeah. So yeah, we'll start with the reed switch, I guess.
Yeah.
Where did I put my reed switch? I had all these parts sitting around here. Where did it go?
The reed switch has left the building. So Lynn is asking, can you use old TV remotes?
You can reuse an old TV remote for an emitter. So it will transmit the light, and then you need an IR receiver. Now, what's in your TV operates at 38 kilohertz. So that's a little bit more involved. I'll discuss that later too, because it's not a simple light signal that steady signal that breaks. I'll have to explain it later.
Okay.
But yeah, you can use a TV remote. So here's a reed switch. I can barely get a hold of here.
Boy, those are like thin.
Yeah.
Okay.
So what that looks like on the inside, just like basically two little pieces of metal in there.
Is it like a light bulb almost, that glass around it?
It is glass. It doesn't light up or anything. It's not a light bulb, but it's just a piece of glass, and it has two tiny little pieces of metal in there, just like that.
Like an insulator.
The glass insulates it. These are conductive pieces of metal.
Okay.
Like flat pieces of wire.
Okay.
That kind of a thing.
Gotcha.
And it operates with a magnet. So what did I do with my little magnet? To show you. I got one over here. So I got these little magnets here. And basically what happens is you take the magnet and you put it over the switch, and it pulls those two together, and it looks like this. So it makes a contact. So it's just like a little switch, like your light switch.
Right.
Okay, so it's basically what that is a switch, just like your wall switch.
So where is that magnet going to be located? Is that like in a rolling
On the
stock?
bottom of your train.
Okay. And then what kind of magnet is that? Like one of those, forgive my, how do you say that? Neo, whatever. Is that one of those heavy duty kind of magnets then?
Neodymium,
Okay.
rare earth magnet.
That's a pretty simple, it seems to me, since I'm understanding of things, it seems a pretty simple way of doing something. I like that.
It is. Yeah. So you can understand that, like a simple switch. So when your train goes to a certain point, it hits a switch. Easy enough?
That is very easy enough. I like that.
Okay. Now I'll show you how this actually operates. One thing you want to do is have the magnet offset from the middle. If you put it in the middle, it's not going to work.
How come?
So what I did is I put the switch in the track here, or under the track. It's actually under it.
Okay.
That's kind of centered. And then on the car here, the magnet's off to the side. And it doesn't matter which side.
Oh, I got you. I got you. Okay. All right.
Just so it's not in the middle.
I understand now. Okay.
Okay. So put that on our track. I was going to get another camera, but let's see. We just scoot that over here. And do I have everything wired up? Yeah. So that when that magnet, there you go.
Yeah, it lights it up. Okay.
So the magnet goes over the switch, and it lights up.
That's pretty neat.
Yeah.
So would that be something that would be good for using for like crossings and stuff like that, for animation in your crossings?
Well, what that's doing is, the train's going to keep on moving, so it's not going to keep going or stay on.
Understood. Okay.
Yeah. So you would have to use that switch connected to something else, like a timer circuit, or connected to, something that will stay on for a couple seconds.
Okay.
Or whatever you want it to do. So that's what I'm saying. I'll show you how it works, and then what you do with it after that. There are a number of different things that you can do with it. Now, if your train's coming down and you want to make sure that the switch is turned a certain way so you don't derail, you turn out.
Right.
So you come down, and that momentary on will switch your switch.
Oh.
Right?
Okay. I like that too. I didn't even think about something like that.
Mm-hmm. It's a simple enough thing. I wonder if I had anything else on that. Check out my notes here. I have to get back to that one. So yeah, what you do with it after that, there's a number of different things. And again, we talked about Arduinos that you were like, didn't want to get too crazy about.
No.
But, you can use that as something to activate something in an Arduino. And that's a whole other project. So there's something else I can do with that. Let me put this away so I don't lose it. And these are pretty cheap. I'm crazy. I bought like 50 of them for, I don't know, $8. It costs like 6 cents a piece.
And where are you getting them at? Just Amazon or like
eBay.
a hardware store?
Yeah.
eBay. Okay.
Yeah.
Okay.
Yeah. So yeah, I order things like that in bulk. Yeah, 6 cents. And if you just want to experiment, you can go to the dollar store and get one of these, and inside of it is one of those reed switches.
Really?
Uh-huh.
I know you had something else from the dollar store. I don't remember what it was now, a nightlight or something, and you pulled out one of these sensors that had, it comes with an LED basically on the inside of it.
Right, nightlight.
So this is a good, cheap way to, quick way to like practice on something too.
Right, to experiment. You don't want to, buy a ton of them or,
or see if
like
that's what you want to use, or if you want to switch to something different.
Right, you can get something like that and try it and see if it works for you.
I'm really liking these reed switches though. They seem really simple.
it's just a switch, just like an on-off switch. So
Like switches for Nieces. I think, like the, what is it? The Microsoft for Dummies. This is like switches for Nieces.
And what you could do, I don't want to confuse you. Let's see that. So you can have your reed switch right here.
Yep.
And you have your voltage that goes in. And when you turn that switch on, it turns on a relay.
Okay.
So then you could have other things connected to your relays. You don't want to have, no, the reed switches are going to work just fine on the LEDs because it doesn't use that much current.
Right.
But you don't want anything that's going to use a lot of current going through that reed switch because it's not going to handle a whole lot.
So maybe this is a silly question too, but it appears that all LEDs are not the same. So is that true in the LEDs that you would use for this? Because it seems like, I mean, I'm going off like Christmas lights. Like when you buy LED lights, I was under the impression that LED didn't put off any heat and all that sort of thing. And that's not true. Some LEDs are giving off heat and some of them are not.
A tiny bit. Are all LEDs the same? Well, they're
As far as voltage or what they're putting out, like, do you have to
they're pretty much all using the same voltage.
Okay.
Like the ones in like LED lights that are I'm trying to think, like little surface mount ones, have the tiny LEDs will use less energy. But any LED would work with that switch.
Okay.
Any LED is not going to draw too much current to ruin the switch.
Okay. Is there something else out there that people would use, not realizing that it draws too much power?
Yeah, if you had something like a motor to operate something, yeah. So then, yeah, you want that motor directly going through the switch because that would probably draw maybe half an amp or an amp, depending on what it was. Okay. So if it drew too much current, then yeah, it would burn up your switch.
And the LED is so that's your notice or notification that it's working, that it's on, that it's done something. Okay.
Yeah, you can do it that way. Give me just a minute here. If I wire this up a little bit differently, I'll show you something else you can do with them. Unplug this so I don't screw it up. And I want to take. So I'm going to show you something else you can do with two relays and using the reed switches. So I'm going to use two different reed switches. There's no power.
And what gauge wire do you normally use for these things?
I think this is like 22 gauge wire.
Okay.
It's just like, what do you call it, control cable?
Yep.
It's, yeah, nothing that special.
I'm just over here taking notes.
Yeah, this is nothing, special as far as the wire goes.
And you built that little circuit board?
I did. Let you remember what I did here so we don't burn this up. think I did that right. I hope I did.
No, do you use like any resistors, or do you need to use any resistors on this stuff?
On the LEDs, you do need a resistor in line with it because you know, the amount of current that goes through a resistor, you don't want to burn up the resistor.
Gotcha.
Oh, I got to plug in my power supply.
Hi, Tammy. Welcome. Hey, Steve. Hope I didn't miss anybody. Oh, Artie. Hi to Artie and Thomas Grassi. Did I miss anybody else? I'm like I'm so trying to pay attention to what I'm learning here. I'm like in a zone. Please forgive me. Heath is here.
Heath is here. All right.
Heath is here.
So what I did here, I want to show you. There's a reed switch here, and there's a reed switch here.
Okay.
So what I'm going to do is back that up again. Hold on, reset this. Oh, lost that wire. Just a minute.
Okay.
I'm going to go back and fix this. Wires are coming out. I'm supposed to turn it off.
Hey, Derek.
Okay, let me see if I can. Okay, I had this working earlier. I'm sure I just wired something up too quick.
Blame it on Heath.
Blame it on Heath. Is Heath here? Okay.
Heath is here. Hashtag blame Heath.
Hashtag blame Heath. Okay, so we're going to start your train over here. It'll hit the first reed switch and turn it on.
Okay.
And then come down, hit the second one, and turn it off.
Okay.
So that's how you do that. And that's what's called latching relays. So you set up two relays. Now that's a little bit more involved.
Right.
But that's how the circuit works here. And you have one that turns it on and one that turns it off.
Okay. That's called latching.
So you would have two different reed switches, one to turn it on and one to turn it off.
Mm.
So you have your train going down and go past the house or a building and turn all the lights on. And after it gets past a certain point, it turns them off.
So that's something that I could do for the crossing signals.
You can do that.
Okay.
Yeah, so you'd set one switch on each side of the crossing signal.
And that's called a latching relay.
That's right.
Okay.
Latching relay.
And that's still using the reed switches, correct?
Yes.
Yes.
Simple enough.
Yeah, I'm learning. I'm so excited.
Cool. Oh, so, okay, so that covers what I have on that, other than the video.
Okay, so
Can I play the video or can you?
I think, I don't know if you can bring it up. Which one is it?
The first video. Let's see.
Under the track here is a reed switch. Under the track here is a reed switch, and that's connected to a timing circuit, which is connected to the power to the track. And on the bottom of this car is a magnet.
Is that it?
I guess that's it.
Okay. I thought I had to go around twice. But I guess I cut that video short.
Yeah.
Unless you want to play it again. So that's another application or another use for it. I have it connected to a timing circuit to stop at a train station.
Okay, that's pretty neat.
Yeah. Cool.
That is
Did
cool.
we forgot to do the trivia thing or the question thing.
Oh yeah. You had that little thingy you were gonna
Don't
hold
say
up.
what it is.
Oh.
So I'm going to show you a tool here that I found in a box. I bought a box of stuff at the train show, and it was at the bottom. I just thought it was interesting. So don't put it in the chat what it is. If you know, answer it later. So this is something. Where'd it go? My document camera's not up.
Oh.
Did I miss any questions?
There you go.
Yeah, here we go. So I found this tool in a box of junk that I bought at a train show. So don't say anything now, but
yeah, what is it? Does anybody know what it is? Anybody?
It's all the sensors from all the worlds. Happy Valley. I just realized I didn't advance my comments here.
Rick says it stops like the subway stops.
Yeah, right. Like a subway stop. Oh, you weren't supposed to say that, Wigwag.
But we asked the question.
Put it up there. Yeah, I'll show how it works.
All right, Steve, take care.
I'm going back and looking at comments here.
Oh, you're fine.
We got time yet? Half an hour. I use LEDs when I make signals. They're 3 volt and 20 milliamps. Just want to see how plot the LED. Yeah, that's correct. See, Thomas Grossi put a comment in there about LEDs.
Yeah.
So generally, any LED uses 20 milliamps, whatever color, and they got like color changing LEDs. And actually, these particular ones you can use on AC, like your Lionel, and you don't have to do anything special in there, and no work with that. Yeah, remind me at the end of the show here, and I'll do show you how this works.
Okay.
All right. Let me get back down here to comments. All right, Steve 87 got to go. Okay, so that's reed switches. Cool?
Okay. Cool.
All right, let me unplug this before I accidentally burn something up and disconnect all my wires here, and we'll start over with the next thing here, which is the next thing is a photo sensor. Photo sensor is something that detects light. Well, it doesn't detect light, but it's light sensitive, whatever. Let's see, we're done with this drawing.
So a photo sensor, would that be like a nightlight that runs when that turns on when it gets dark, kind of a thing?
Yes.
Okay.
What did I do with my photo sensor? So that's a photo sensor. And what happens is when light hits it, the resistance decreases. When there's no light, the resistance increases. And you were asking about the night light. So yeah, you get one of these guys from the dollar store.
Yeah.
And when you tear it apart, like I have to do with everything, tear it apart. Right here you have a photo sensor. So if you want to experiment with photo sensors and don't feel like ordering them on the internet, you just want to go to the dollar store, you tear one apart, and there you go.
Nice.
So you can see that.
Easy peasy.
You see that easy enough?
Yeah, I was trying to make it bigger, and it's not.
Well, I can make it bigger like that.
Okay.
Yeah, so you get one of these night lights at the dollar store, and that's where the photo sensor is right there. And you tear it apart, and there you go.
Boom. Nice.
Okay.
Another easy way to test something out before you.
Yeah, an easy way to experiment and mess around. So, like I said, they are light sensitive, so that wouldn't work too well in a tunnel or something like that.
Okay, because it's always going to be dark in there.
Right. Which is the problem I had with my Lionel because there's another layout above it.
Right.
So I have to put LEDs underneath to shine down on the photo sensor, or else it will always be dark.
Okay, that makes sense.
Makes sense. Okay.
Okay. So it's 2 items that you can go to the dollar store and get for $1.25 and test it out before you buy something.
That's right.
I like it. I like it a lot.
So a photo sensor is, well, it's a photo resistor. Like I said, it increases or decreases into urban line.
Oh.
Do you want something to go back and forth, like a point to point, or you want it to, yeah, you could use it for your interurban line, but what do you want it to do? I mean, yes, you can. There's a lot of different things that it'll do. Let me see if I can get these wires in here and not break something.
Heath says that a photo sensor detects when people take pictures. That's quality.
Heath,
Aww.
you jokester.
Oh, light in the tunnel. Hot Rod Rodney says, just add some light in the tunnel, but then it wouldn't be a dark tunnel.
You can do that. And that's what I did on my Lionel, is I just put a light above where I wanted it to work. So
Ray says point to point, but it would have to switch out. He says he will hit you on the side.
You know what? I forgot to do a video of my point-to-point controller. But yeah, I did all these videos. I have a trolley that goes back and forth. That one I use the Arduino for.
Hey Nathan, welcome.
Who's that? Nathan Delay?
Yep, Nathan Delay.
Nathan Delay. Bear with me while I try and blow this up here.
Ooh, blue smoke?
Yeah, yeah, the blue smoke. Again, we're just using a LED just to show you how this works without getting too crazy. I can't get that in there. Okay. I had some notes on that. Can place under the track. You need light to make it work. And as light increases, resistance decreases. So I have a circuit here that uses just a few small components. There's your photocell, and that's a transistor. And that is a adjustable resistor, a variable resistor to adjust the sensitivity. So we said that the resistance increases when it gets dark.
Mm-hmm.
So when it gets dark, it'll increase resistance, and the voltage would be higher here, which will turn on the transistor. So you could think of the transistor as like a valve, a water valve. So you open that up, and then the electricity goes through it.
Okay.
Easy enough?
Yeah, that makes
kind
sense.
of.
Yeah.
You've never wired a transistor before, though.
No, but I understand what you're saying about the power, like the flow.
Right. So it's like a little valve or a gate right
And
there. So you put
yeah.
voltage there, and then it turns on your relay.
Hey, Ray, it's a dam. Holds back the power And then you open the dam.
So in here is my photo sensor. Can you see that?
Yeah, just barely let you.
Just barely.
There, you kind of see
Yeah,
it.
right
Okay.
there. That's my photo sensor, right there. Do I have a power plugged in? Nope.
And you said when you did that you didn't drill a hole. You just used like a round file and filed the rails. And then
I did on the HO, and I guess you'd want to do that on the end track.
Okay.
Yeah, you had to open that up just a tiny bit in between the ties to get that to fit in there.
And then
yeah, if you try and drill straight into it, you're going to end up breaking those ties. So you take a small file and just kind of, open it up just a little bit.
And then you recommend putting glue on the underneath so you don't get glue on top of the sensor.
Yeah, I mean, you could put a tiny dab in there and then pull your sensor through, or, if you could do it from underneath. I mean, here this is movable, so I can easily glue it from underneath. I guess if you use hot glue from underneath and let it drip on you as you glue it, that'll work too.
Let it drip on you. I think I'll pass on that.
I mean, just basically whatever you do, don't get a bunch of glue on top of your sensor, or else it's not going to work.
Yeah, don't push it down after you've got glue in your finger. And then...
Yeah, right. Don't get glue all over your fingers and, make a mess out of it. Yeah. All right.
Rick says that dam works better than Ray's at the moment.
So I just made that little thing to hold on to. So there's your sensor. And what did I do? Oh, we got to adjust this so that power's on. And this is not plugged in. One of my wires came loose. This circuit better work for me. Better work for me. You gotta be kidding me. Something isn't right, because that should be on. Well, that's not good.
Uh-oh.
Uh-oh. What if there's something wrong with my circuit board? That's positive, that's a negative.
Yeah, everything. When you're live, everything likes to play games. Things
It sure does.
Microphones don't want to work, and lights don't work, and trains don't like to run, or that's when they run off the rails, even though they've been running for 4 hours straight.
Yeah. Well, actually, I made these video clips like an hour before we started, and that was nothing but a problem. I'm starting over with a different board.
Okay. Deep Run says Microsoft didn't reboot it. Somehow, Mike, I don't think that's going to work.
Okay, at least that board works.
Nathan asked, what does STS mean on the paper behind you?
It's Sidetrack Sunday.
We're professionals, don't you know?
Yeah. All right, something's wrong with that board. Back to the shop.
Yeah, it's lit up now. The dam is open.
Well, it's lit up now because I don't have the sensor connected.
Oh.
So it won't turn off. There we go.
There
So
you
I
go.
connected the sensor, but actually it should be on now since it's covered up. So we need to adjust this. And I'm probably going the wrong way. Come on.
I just like the fact that all these different sensors that are available are something that you can use in a lot of different ways. You're not just stuck with a sensor for a specific reason, specific topic. Like you can use it for crossings and signage and animations and lights and all kinds of things. And it's
Right.
cool.
Depending on how you want to use it, there's different ways you can, different sensors you can use for different purposes. And like I said, you wouldn't want to use a photo sensor in some place where there's no light because it won't work.
Right. Yeah, that would be funny. That would be something I would do. I'd put a photo sensor in the dark and then wonder why it didn't.
Okay. So that's on. So when I move that away, it should turn off. There we go.
Hey, Randall.
There you go.
Ta-da.
So there's the photo sensor. Let's see. Train goes over it, blocks the light, turns on the transistor, turns on the radio. I mean the relay.
Yep.
And you go past it, and it works.
Nice. Now, do you have resistors? Are there resistors that go on this as well? Is that something like if you have an LED, then you need a resistor?
Yeah.
Okay.
I think they make LEDs with a resistor like included in it.
Okay.
But anytime you use a resistor, anytime you use an LED, you need some kind of resistor in there,
So you don't blow up
depending
your
on the voltage.
Okay.
Yeah. So what was I going to say? The advantages and disadvantages of using a photoresistor to a reed switch.
You have to have a lighted area.
Yeah, there's just different. Yeah, if it's in a lighted area, then it'll work. If it's not lighted, then it doesn't work. So train comes and goes over that, light comes on. Right.
Nice.
And I showed you the relay in the other circuit with the reed switch. So here's there's a relay. So you can literally, so this is switching the 12 volts. So that's what's lighting the LED out of these two connections. But you can have a relay with, I call them isolated, or just, an open and close, and connect whatever you want through it. Like a Lionel accessory. In other words, like AC power instead of DC. Or something like that.
Okay.
Your switches.
Nathan says, can I get a photoresistor that you're using? Would that be possible to get from Amazon?
You could, but I probably have 20 or 30 of them here. I'll send you one.
Let's see. Happy Valley says, what is the oddest sensor you've seen? Oddest or oldest? Maybe oddest.
Yeah. Light sensors. I guess you got vibration sensors. Ohm's law. That's correct, John. Ohm's law. So depending on, it's way too neat. Well, I had to do it more than once. As a matter of fact, I had it. Well, I don't have that drawing, but it was like really small and you couldn't see it. So yeah, I sat here I drew it with pencil, and then went back over it with a marker to make it readable.
It's very, very neat.
I had it really small, like I printed it out, and it was like, nobody's gonna be able to see that.
What's a circuitron circuit?
Circuitron, I guess it's a manufacturer, right?
I have no idea.
Is it? Let me see if I have one of those other drawings. Yeah, here you go. Here's the drawing that I made, with CAD. But
That's small. That's real small and light.
yeah.
Very light.
So I made that so you can actually see it.
I mean, the drawing at the end of the day is still Greek to me. So.
Well, you understand how reed switches work now.
I do.
And you understand what a photosensor does.
Right.
So we're halfway there.
Right. Learning how to read the schematic that's going to be like a whole nother. Circuitron makes the tortoise switch machine. They also make a bunch of circuits. Oh, okay. I would think I'd know that. Derek says, now that I've seen this, I think he can do this. Anything's possible.
Who said that?
Derek Alexander.
Derek Alexander. Yeah, send me an email if you have questions. I mean, it's not that hard. I mean, once you realize what they do. Are there that many comments, or am I just that slow in getting them here?
There's a lot of comments. ECJ
what is blue smoke?
Yeah.
ECJ doesn't. We don't censor anything on this show.
No, not censored. Very odd.
Just whatever. Yeah.
You get what you get.
I keep scrolling down, and then there's still more there. Okay, there's a Circuitron comment. I think I can. Fultz Bailey. This is why I stay in DC. Oh, I'm DC only.
Yeah, I was gonna say this is for DC and for whatever. It's not either one. At least that's my understanding.
Yeah. So it doesn't have to be DC or DCC. I mean, if you want to operate something outside of your layout and use the sensors, you can use it. I mean, I guess they probably have like DCC dump cars and things like that, animation cars. A specific project you want to accomplish.
Well, one of the things that I started to think about was doing the crossing light on my my flashers. Get my flashers going on my crossings. That would be
sure. Or you know what, Nissy? That's one thing that I did do since we're here, because I showed this to Rick. I sent one of these to Rick. This is a whole other thing here. But since we're on the subject, I'll wire this up and show you how this works.
Nathan says, David, I must be asking a ridiculous question when I say this. Can you hook up the electronic that you have? Can it be hooked up to a motor or do something basic?
Absolutely. Now you said to a motor. Now it depends on the size of the motor and so forth. If you have enough power. If it's a small motor, yeah. If it's a larger motor or something, then you would need a different power supply for it. And then you would use like the isolated relay here, like I was showing, and just use, these contacts here. If it was like a larger motor or something that ran off of AC, then you would use those contacts.
Derek is saying, I like that you could use the cheap motion light to do detection on the layout. Yeah, I do too. I like that.
Sure.
Great big expense.
That was my inspiration. At nighttime, I walk past the night light and it turns on. I said, hey, I can use that for something.
Rick says you can use these switches and relays to trigger NCE DCC components.
Yes. I'm trying to wire something else up here. Just bear with me. What's so funny?
Sean said the oldest censor, Eve slapping Adam for saying she was fat.
You're funny.
Oh, I got a new name in here. Barry Olson, welcome. He says infrared resistors at Temu are $5.59 for 10 pieces.
Okay.
Nice.
Well, $5.59. It's 56 cents a piece. I think I got it for 10 cents, but because I ordered in bulk.
Rick is asking, can you run a small servo through a reed switch?
Yes and no. I mean, you can run a motor through a reed switch. Well, not directly. You would want to use the relay for that. But you remember a servo motor works on feedback, so you know where it is. So in other words, like if you want it to go up, then stop, and then come back down and stop, you need a different control. Oh, hi. Heath. Put Heath's comment up there.
Where is it? Oh, here we go.
Something about...
Dave, will you be going to Amherst? They're trying to decide how high to hand the flower pots. What? How
So
high
bang
to
my
hang the
head.
flower? Oh, okay.
I banged my head into one.
Jeez.
So Nissy, this is a circuit that I made, and then I actually was looking at different things on eBay
Right.
or something, Amazon, and you can actually buy this circuit that is like almost a quarter of that size, maybe a third that size, for like $4. And I'll show you what that does here. So here's your photo sensor.
Yep. Flashers! I love it.
So yeah, that's another circuit that I made, but you could buy that circuit for about $4.
Already put together, already built, basically.
Yeah, and you just plug in your LEDs. So this was a railroad crossing, didn't have the LEDs in it, and you punch out the LEDs and drill it a little bit and glue them in there.
Okay.
So, and then
Now, when you say you drilled that, what did you use to drill that out so you could put those LEDs in there?
just a drill bit.
Okay.
Yeah, they have like little plastic red things in there so light shines through it, and you just kind of like punch them out with a screwdriver, and then drill them big enough to fit the LEDs.
Gotcha.
In the back.
Just wire them. Okay.
Yeah, no big deal. And if you need really, really small wire, we were talking about wire before.
Yeah.
If you get like a keyboard cable or a mouse cable or
Right.
USB cable,
Yeah.
this stuff is like microscopic small.
Okay.
Yeah, if you need a really small wire for something. So that's photo sensors.
Nice.
You want to roll the video on photo sensors? The second one.
And the under me or under you? Under you?
The second video. I don't know.
There's a photo sensor right here on the track, and when the train comes by and blocks the light, it will operate the crossing signal.
That is so cool.
So the blinking light thing is a circuit board that I made that I just showed you here. And then I was showing you there were two different contacts on that relay.
Right.
So that Lionel gate, the O-gauge gate, that works on AC power. It works on like 14 volts AC. So that has to go through the isolated relay, the separate relay. Does that make sense?
I'll say yes for now. Sure.
You'll say yes for now.
I'll say yes for now.
The AC power for the crossing gate goes through these contacts.
So doesn't all this stuff run on AC though? Like the only thing that's running DC would be the train basically, and then accessories are all AC?
No, this is DC. The circuit is DC.
Oh, okay.
And like LEDs work off of DC. That's a good question. I was going to do that video too. But yeah, HO accessories do use AC.
Okay.
Like their log dump thing.
Right.
And the HO Tyco crossing guy, or the gate man guy. The gate man guy. He works on AC.
Out. Okay.
Yeah. Yeah. So that's photo sensors, and you saw the video. We should see the name of the streets like Bong Bong. I don't know what that means.
And then two without that video you just showed was the Lionel track, and because the Lionel track is what, taller?
AC.
It's taller height-wise. You had to put some sort of a washer underneath that sensor, or else the shadow of the track would always be in the dark, right?
That's correct.
Okay.
Right. So on our HO track, that sensor kind of hides in there pretty good. It's only like the height of the track. But on the Lionel, it would go down in there too far, and it would always be dark. So you want to put something underneath that sensor to bring it up, you know, so it's so it works correctly. I wanted to go back. Sorry, we were talking about this latching relays. One of them turns it on, one of them turns it off.
Okay.
If you have two-way switches in your house, like in the hallway or something, you turn the switch on, and you go down the hallway, and you hit the other switch, and it turns the light on.
Yeah.
That's exactly what we're doing here.
Okay. Okay, that makes sense.
Okay.
I hate those switches though in the house because one's always the opposite direction of where it's supposed to be.
Yeah, right. It's up, but it's off.
Okay.
Or else the other end is down and the lights are on or something. And you're like, all right, I had these synchronized and somebody messed with them.
PK says, thanks for all the prep work. DBTech, great stuff. I learned things, and that makes it a great day. Great demo.
Cool.
Thanks, PK. That's awesome.
See, I had a little bit of fear that I was going to do this, and people were like, oh, I know that. It's no big deal. This you would use resistor electronics they were showing us. Why would you use it? You had a chance. Well, you were talking about using it for a crossing guard.
Yeah, for a crossing just to start. And then there's so many uses for it, like I can't even off the top of my head, but it opens up another world for me that has been made so much more simple than before.
Yeah. So light sensors would not work during night offs. That's correct, Derek. So you would need like a street light over top of your photo sensor.
Yeah. Let's see. I'm trying to catch up with those.
Keep the breast, give me the thighs. How do we start talking about chicken?
Wait, how did I miss chicken?
I don't know. Somebody said Lehigh River subdivision said something about breasts and thighs. Oh, we got into that.
I'm like way behind.
Yeah. Yeah, so there's two simple things. So I need a drink.
Well, there you have it, folks. David came on my show for the first time, and the man needs a drink.
This is just water. But when we get done with this next part, I got a beer sitting over there waiting.
Oh, no. Do you know who you're talking to? I'm never going to learn it for sure. Oh, my goodness. Let's see. All right, before we
do this first before I crack that.
Oh, my gosh. So
I got a sip left in this one.
Oh, Lord have mercy. Derek says you can make flashing kits. That's too funny. Yes, I can. I 100%.
I can make flashing kits, yeah.
Ian says, or as Cam would say, ding-dings. Yeah. Let's see. Barry says, I don't usually comment, but I watch all the time. I'm going to Amherst by train, the North Shore Limited from Chicago. Sweet.
Okay.
Ding-dongs.
Okay. Are we ready?
I think so. Let me make sure I don't miss a question if somebody had a question for you. Question, Lynn McCurdy. Going back to read sensors, can you use a magnet strip the length of the car? Otherwise, the photo sensor is better, I guess, for whatever he's using it for.
Yeah, you can use a magnet strip. In other words, if you wanted the magnet to be the whole length of the car, you can do that, and the read switch will stay on. Oh, I'm sorry. That was something I meant to say about the read switches. So you have to have one of these cars with a magnet on it.
Oh, that's right.
So if you want the read switch to work, you have to put the car that has the magnet on it. Now, I would not recommend putting it on like the engine, because I don't know if that'll affect the motor or not. I mean, it may or may not. It's not that powerful of a magnet. But
yeah, but some of them have magnets in them, don't they?
Yes, they do.
Yeah.
Great.
See, like Artie. Yeah, that's what Artie's saying. Like, it's a good reminder, too, for those that do know it, but maybe haven't been doing it for a while.
Yeah, that was a thing. You know, when I started this, I was like, "Come on, I know how to do this," and I started looking at it. I was like, I had to go through some books and stuff and figure it out, and it's really not that hard.
Robert Darby says the next circuit can be used on a bridge. Okay.
Okay.
You could have flashing kits rethink it. Rethink it. I don't have to think too hard. I think I figured it out. I think you can also make somebody loading stuff that's motor driven with the light sensor. Okay?
Yes, you could. Yeah, that would work.
And Rick is offering Gray. JD said he had Bailey's. Apparently they made a mint chocolate chip flavor. Doesn't sound very tasty, but hey.
Yeah.
All right, so what's the, I'm already like covering my face. Like, what's the next sensor that you're going to need a frosty beverage after?
Yeah. IR sensors.
Infrared. I know that much.
There you go. So that's an infrared emitter and a detector. Okay. So, and I showed you with the remote control on the TV. Oh. So there's your remote control.
Okay.
Okay, and what's in there is that.
Gotcha.
It looks like an LED, but it's not. It well, it is an LED, but it emits infrared light and not white light or visible light.
Okay.
And then that's the detector. So when the light hits it, resistance decreases. So
it turns on.
That's how that works.
Okay.
So we talked about ways to get these cheap and experiment with them.
Yep.
If you got a paper shredder and you throw the motor burns up and you throw out your paper shredder, you'll find these guys inside.
Really?
Yep.
Okay.
And if you have an old printer, you know, regular old like inkjet printer or whatever,
yeah,
and you tear it apart, you'll find this inside. And one of these is an IR emitter, and one's a detector. Trying to keep that so you can see it. Now this black thing there, that's just a piece of plastic.
Okay.
If I don't know if I, no, it's kind of like molded in there. It'll break if I take it off. But well, I mean, you could carefully break those off, but I'm not going to do it now. But yeah, so if you got an inkjet printer or whatever, right, you'll find something that looks like this inside of it, and you can experiment with high pan contacts.
Never heard of it. Keith wants to know what an infrared emitter admits to.
What it admits to working or turning on or being sensitive to light. Where did I go? Okay.
Oh, you can use infrared sensors in the dark. They don't have to be in the light.
That's correct. So that's what I was going to get to. Okay. So we talked about the photo sensor, photoresistor, and that's dependent on the light. So you couldn't use it in a tunnel. But with the infrared, you can use it in the dark and it doesn't matter. How's that sound?
Sounds good. Jerry asked, David, do you have a video on your channel about these tips and projects?
I do.
He does. 11 months ago.
I'm trying to figure out now. If you look up, if you go to YouTube and you search for DBTech Gate Man, you'll find one on infrared sensors. I don't know if I did one on the photo sensors. And where did I do one on read sensors? I'll have to go back and look. Yes, there are videos on some of these in there that I've actually used. And, oh man.
JD says dinner's calling. Wait till
I know my point-to-point controller for my no, that one uses IR also. Let me wire this up real quick here. Go ahead, talk amongst yourselves while I burn something up.
So why, Artie, why is Ray turning into a mushroom? I'm very confused. Please explain. Please explain the mushroom comment. Don't understand.
Because he's in the dark?
Oh, that could be. Sounds like he's a fun guy. I couldn't resist.
What did the mushroom say to the toadstool? You're a fun guy.
Oh, Lord have mercy.
There's a Rainbow Bell joke.
Exactly.
Quick, get Rachel.
Exactly. It's like the perfect thing.
What did the mushroom say to the toadstool?
Too funny.
Okay, let's wire my power up backwards here. Let's see. Where's the positive and where's the negative?
If you offset the magnet and reed switches, you can have it directional, working in one direction, but not the other way. Okay.
Yes. And I don't know. I mean, what else could you use these for? What other kind of things would you want to work? I mean,
It's almost like experiment and figure.
that's all I do.
Artie says it explains why his layout construction is so slow. He's working in the dark.
There you go. Artie needs one of those lights on his head.
But Ray got his 3D printer up and running, and it printed something, so maybe the light's on again.
Well, how cool is that?
Toilet paper couldn't cross the road. It got stuck in a crack. Oh, come on.
Shut up.
Jeez.
Blew my concentration.
Concentration. Who needs concentration?
What am I doing? Okay, I need to. How are we doing here? Are they going to run away? It's after 9 o'clock. Are people going to start dropping off here? Or are we all right?
I think we're all right. I don't care. I want to know.
Okay. Missy's learning stuff.
We're going till the wheels fall off.
What's that? Till the wheels fall off?
Till the wheels fall off.
Okay. We'll keep going.
Steve's 87th is back. He says his chores and dinner are done. He's back on the couch.
Well, that's good. That's good.
Oh, Boxcar Jerry. He's joined the fray. Had a dream last night. I was being chased by a muffler. I woke up exhausted. Ray says, constipation, have to wait for the toilet paper. Wait, what? No. Nathan says he's not leaving till the stream ends.
Not leaving until the stream ends. There's dedication. Thank you, Nathan.
Heath and ECJ just asked you to join the show so that she can learn. The heck with the rest of us. Yep, it's all about me. It's my show, it's my STS, and it's all about me. You're all my
right.
minions.
It's all about you.
Let's see. I'll stay and see this bit. Then I need to go and buy new thongs for my U.S. trip. Oh,
okay, hopefully
Artie,
I get this done in a minute here.
Artie, stay down under. Hey, it's Russ Rockin' ORR. Hi, Nisi, everyone. Welcome, welcome, welcome.
Is Boxcar Jerry in the chat?
Oh, Boxcars, he joined the fray. He's been telling
Jerry,
me
did I miss you at the train show yesterday? You said you were going to be there, and I thought I looked for you once or twice and then forgot. So I don't know. Were you there?
Oh, Randall says he slid around in ice and snow and he needs a relaxer. Oh.
A relaxer, a muscle relaxer.
Derek says not leaving till the stream ends and the opposite of constipated. LOL.
Okay. Let's see if we can plug this in and see if it'll work.
Oh, it's on.
Ah, yeah, of course it lights. Okay. So.
Yes, thongs are illegal in the States, Artie. Stay down under with that.
I can't see what I'm doing here. Come on. Trying to see if that IR emitter is working or not, or if I burned that one up.
Why did the chicken cross the road? To get to the idiot. Knock, knock. Answer the... Oh, Lord have mercy. Y'all are getting worse. You're getting worse. Eric, welcome to the fray. I don't know what's happening in chat. We talked about chicken, and thighs, and all kinds of things tonight.
Ah, okay. So you have an IR detector, an IR emitter. I was trying to test this, and for some reason, I can't see the little purple light there.
Nathan says he sees a bit of purple on that light.
Okay. You can see better than me.
Yeah,
So the light is on there, and if I line these up,
it turns off.
Turns off like that.
Okay.
So this would go. My little test track here. And I lost the screw, so I can't mount this other thing here. So we're going to have to imagine.
Pretend it's been bolted down.
Yeah. Well, I'm going to have to hold it is what I'm saying.
All right. So you have a sensor on either side of it. So when it passes between the two of them, it's going to break the circuit, basically.
Basically.
Wow, I'm learning things.
Yeah. So this is an emitter, and that's a detector. Go like that, and you can't see the light. Here we go.
Like the garage doors.
There you go. Exactly.
It's like a garage door. Okay.
There we go. You see that? I keep putting my hand in the way.
Yeah, but you can still see what you're doing.
I mean, you can see the light. There we go.
Yeah.
You
can hear it clicking.
The light? Can you see the light?
You can't, but I can hear it click. I don't know if that's the train, but it seems like it's clicking when you're... There it is, yeah. You can see the light.
So these little guys I made on the 3D printer. Okay.
Nice.
Cool, huh?
That is cool.
So you can use that just the same as like the photo sensor. You know,
right.
The difference with this is you don't need regular light. You know, you could do this in the dark because it has, you know, this is an emitter. It has a light.
It provides its own light because you're breaking the light.
So it's not dependent on the ambient light. Now, you see the light, sorry. Okay, so we understand how that works. Now, I know that this circuit here is a little bit involved. I mean, that's how this works. You have your emitter here, the detector there, the resistors, and this is what's called an op amp. So it detects the difference in the voltage. So in other words, if one is higher than the other, then you get a high output, no, a low output. So if they're both the same, it would be high, low. I don't know.
Dave's like, I need a beer.
Here it is. Oh, I even wrote my notes on here. Yeah. So
if it's high.
Yeah. If these two are the same and they're both high,
yeah,
you have a low output. If one's high and one's low, you have a high output. Yeah. So a high and a high gives you a low. Which will turn on the resistor.
I said it. I did it right. I said it right.
Yes.
I did learn something. Something stuck.
Yeah. So that's a little bit more. I mean,
that's more involved.
Yeah. I mean, that's the op amp right there. Okay. It's a little IC chip. Just got to know where to connect the pins. It's not that big of a deal. It's a couple resistors and a couple pins.
Yeah.
470 k ohm and two 10 k ohm resistors is basically what it takes to make that to work. But you know, I mean, it's all there is to it right there. So yeah, the advantage is that you don't need ambient light, or the ambient light won't affect it. Now the difference is sometimes if you have certain lights in your house, the detector might pick it up.
Right.
It's not likely, but it's possible. So it's something I guess you need to test and see if if it's a problem or not. If you were going to use this outside, it would be a problem because infrared light does come from the sun.
Yeah.
And it would not work on an outdoor layout.
Yeah.
So that's why you would use what's called 38 kilohertz detectors. In other words, we talked about remote controls, and it actually sends pulses of light, not a steady light. So if you use that circuit, which is what you're TV remotes work, and the sensor that's in your television uses 38 kilohertz. In other words, a flashing light. So you can use that outside. Did I just confuse you?
No, that makes sense.
Yeah.
Good night, Eric. Take care.
So you can use that. So that's infrared sensors. And again, you know, you can use that for a variety of things. You know, control animations, lights, log dump cars, whatever. You want to roll video number 3?
Yeah, Barry asked a question. Is that a 555 chip?
No, that's not a 555 chip. That is a LM358. LM358 op amp. I used the 555 for the timer circuit in the train station, the first video that I did. That uses a 555 timer. Yeah, you want to roll the video?
Here's your IR emitter and your IR detector. And
sorry, the Smurf is in the way.
When the train comes by and breaks the beam of light, it operates the gate man.
Well, that's cool. That's very neat. Hey, Gus, welcome.
What's that?
I was saying hello to Gus. He just popped in.
Oh, Gus. Gus is here.
Gus is the man. Wow, that was a lot, but I'm very excited. That's actually very, very cool.
Uh-oh. Table fell.
No. If you strangle a Smurf, what color does it turn?
Purple.
Dark blue.
Dark blue.
Purple. JD says purple. So are you gonna tell us what the thing was that you held up earlier?
Oh yeah. Let me clean some of this junk up here. So those are just some uses. You know, I showed you 3 different uses and different types and advantages and disadvantages. I mean, if you've got something that you want to control, and you know you got a project. I mean, I'm always trying to do different things here, so I would be interested in knowing what you do with them. If somebody's doing something different, I'd like to see it. What I wanted to do was show you. I forgot to record a video of my my trolley, and it's a point-to-point controller. So in other words, the trolley goes to the one end of the track and stops and goes back. And maybe that's another video or something.
Yeah, that's what Ray was talking about earlier, was something for his point-to-point.
Yeah, the point-to-point controller. And I do have that, but I forgot to make a video of it.
So JD says, if you squeeze a Smurf, what do you get?
What?
Please, JD, tell us. Please tell the rest of the class.
What do you get if you squeeze a Smurf?
Yeah, we're waiting.
Smurf juice?
Ew. Oh. Smurf juice. What? Smurf juice? Smurf slime. I'd rather go with slime. That's still not good. It's gross.
Never mind. I can't say the
other thing. And there, folks, we're off the rails. But we did good. We stayed on the rails for an hour and 20 minutes.
For how long?
An hour and 19 minutes to be exact.
Ah, we did good. We did good.
Yeah, we did really, really good. Wow. Does anybody else have any other questions or disturbing Smurf jokes to share?
So you wanted to know what the tool was for?
Yeah, what is the tool for?
All right, you want to show me my document camera again? Smurfs and Lemmings.
Oh.
Mushroom sauce.
Yeah,
there we go.
There you go.
So if I turned it the other way, that would kind of give it away.
Looks like you put something
slot in it.
Yeah.
And these railroad spikes, somebody did guess what it was, I think. So these things actually look like railroad spikes, kind of, if you can see that, I don't know.
Yeah.
I'm looking at this almost from across the room. The laptop is all the way over there.
That's
So, so there's a little magnetic pin in the middle that's going to stay in there, hopefully. And then you put that on there.
Ah.
Just like that.
Just,
oh, okay. No, wait. Those are different nails. Let me see. I was trying to show you.
Heath has a question. He said, if you have a reed switch, here, let me put this out for everyone to see this one. If you have a reed switch, a photo sensor, and an IR sensor on your workbench, what does 1 + 1 equal? It's the circumference of the sun. There's your answer. Circumference of the sun.
Darn it.
Sidetracks 77.
I just realized.
Have you ever used Hall effect switches? Hall effect?
I have not. I mean, I can't remember what they are.
Yep, we talked about scientific circuits to Smurf squeezing. I mean, we run the gamut. Thank you, Liz.
Lindsay H.O. It's motive power. $3.95.
Wow.
So I found it in a box.
What's the date on that?
I'm trying to figure out here.
Nah, Smurfette has a harem.
Smurfs need more women. Yeah, there's one Smurfette in the whole village.
Yeah, she's got a harem. Ray just said it's 1950. Thomas Grassi said 1950 as well.
I would guess, it's not real old. Well, it's $3.35. So
Artie says his cost him $30.
$30. Well, that kind of money. 1950.
They're like reed switches with the size of a die.
There you go. You can see that better. I think.
Oh, okay. Yeah.
That's what's really supposed to go in there. Find the other box. And I guess this magnet isn't working all that great anymore. No, kind of works. So yeah, if you wanted to nail down your track just like the old days, make a mess out of it. I never used it for anything more than what I just did there, just for the fun of it. So we'll put that back in the box. All right, so yeah, if anybody's using anything like that, I'd like to see what you're doing. I think if you look at my my name in Trolley or something like that, you'll see my point-to-point controller. And if you look up DBTech and Gateman, you'll see the IR sensors. And it seems to me I did a whole video on photo sensors. I showed you that, Missy.
Yeah.
Yeah. So if you do a search for DBTech and photo sensor, it'll show you the whole thing. And yeah, if you got a project that you're trying to figure out, let me know. I'd love to, see what you're doing. You can still buy them. Oh, okay. What does DB and DBTech stand for? It stands for decibel. I told you that. So he keeps asking me that.
He's always has the questions.
Oh, there you go. Thanks, John.
John's always on it. Thank you, thank you, thank you. Does a real spiker have a zip code on it?
Oh, okay. I know. Yeah, for manufacturer, that's a good question. Trying to figure out the date. That does not. Where's the piece of paper that I had? In other words, if it has a zip code, it's after 1970, right? Or 1960. Did I find my thongs? No.
No thongs. Artie, no thongs. Save your money.
I don't have an address on here, Edward, that has the an address that would have or not have a zip code. So, Lindsay, that looks like didn't they make like sewing equipment and stuff?
I have no idea. That name does not ring any bells for me.
Pipe and contacts, contracts or contacts. That does sound familiar. Is that like the things that went underneath the track? Is pressure sensitive?
Nightland, take care.
Well, the bottom of the paper is missing.
Yeah, the bottom of the paper has seen better days. Better days. Oh my goodness.
Hey, look! I just got a notice. We're live.
That's our my calendar for the last 2 weeks. I will go and do something that's a thing that was on my calendar. I will have done it, come home, and like 11 o'clock at night, my phone goes ting, and then my calendar says, today you have to do blah, 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 and blah, blah, blah. I'm like, well, it's a good thing I already did it because it's 11 o'clock at night, and I would be really late or not get it done at all. So, yeah, I don't know. The internet is just so good these days. Lindsay is an old model kit maker, most planes and model cars is what Lynn is saying. So, yeah. Good night, Lynn. Good night, John. And, oh, I think that's it. I'm learning it. There's so many Johns. I'm trying to keep track. Yep. Okay.
Well, I think that worked out pretty good other than my cameras here and whatever. But
no, I think you did. I think it worked out fine. I mean, you can see everything really well. The videos were really good. I think I had a lot of fun and I really enjoyed it. And everybody stuck around and hung out with us, and that's really cool.
How many did we have?
I don't know. Oh, it looks like it says 33 right now, but I think at one point we're at like 42.
Yeah, all right, good night, John.
Yeah, good night, John. Good night, John.
Where did I learn all this stuff? I've been in electronics since I was a kid, I guess, and to get these circuits done, let me hold on a second. Let me get a book here.
Oh yeah, in 2 weeks. So next week is.
Trip over the lamp.
Oh no. Next week is the third Sidetrack Sunday of January, and that will be on Rick's channel. And then the week after that is the 200th STS show, and I believe that is on Ray's channel. Thanks, Edward. Thanks, Mike.
Yeah, so most of what I did,
thanks, PK.
like you can search this stuff on the internet, so it's not like I designed it from scratch. Just kind of went to the internet and looked some up. You can like the thing with the IR sensors. These are books that Radio Shack used to make by Forrest M. Mims there.
Oh, they're handy.
Yeah, no, they make this is like 30 years old, but you can buy a book that has like all these different topics in it.
By the guy.
It's called Getting Started in Electronics.
Okay.
By Forrest Mims. So if you want to, yeah, that's a good book for you, Nissy.
Yeah, I'll write that down. Getting Started
in Electronics.
By Forrest Mims.
Forrest M. Mims.
M. Mims. The third or something like that.
Yeah, something.
Okay.
But yeah, a lot of that stuff is right in here. And so, yeah, you find all kind of stuff in there.
No blue smoke, Steve. We did it without blue smoke.
I can't believe it. How do I fix my problem? Buy more drill bits.
Yeah.
Actually, Heath, I was going to ask you because I need more 1 millimeter drill bits to make my circuit boards, and one of them I broke, and one of them wobbles all over the place. So I have one drill bit left.
Oh.
So I need more of those.
You need more drill bits.
Yeah, how good of a drill bit? How much do you have to spend for a good drill bit these days? I don't know.
Do they exist anymore?
I don't know.
Ken says learn how to use them.
Drill bits?
Yeah, he's saying that to Heath. Learn how to use them, then they won't break. Yeesh.
Well, that's true. There is a right way to use drill bits other than just taking it and as fast as you can and as much pressure drilling it into something.
He says he buys drill bits in packs of 10. Why are you buying? You got to be buying them on. Yeah.
No, I buy them in packs of 10.
Really?
Yeah.
Is it because it's just getting used so much? Drill bits, I keep screwing up. Oh boy.
Because I wear them out, and because break them too.
I've never.
You wear them out and you break them.
Oh, I've never. Russ says 1 millimeter roll front. Well, yeah, because that would be really. But what would you use 1 millimeter for? I guess for like the circuit.
I need the 1 millimeter to drill out these circuit boards.
Okay. Oh, you know what? When I'm thinking drill bits, I'm thinking, like where you're drilling into wood and stuff. I'm not thinking about the little handheld little drills. I'm sitting here looking for mine and they're not right in front of my face. Yeah, I forgot about those. Yeah, those are easy to break. Now I understand what you guys are talking about. Yeah.
But well, even 1/8 inch and 1/4 inch, I buy in packs of 10 at Harbor Freight because they're standard sizes and I use that many. 1 millimeter by 1/2 inch bit person's 10 foot tall man who's with. Well, if that 1 millimeter drill bit,
that could hurt.
Yeah, that could hurt. If it goes through my hand, it'll hurt.
Yeah, that could hurt. Barry says, got carbide drill bits from Temu. Carbide. That sounds like it'd be strong.
That's true, Ken, and you're right. If you use drill bits properly, they won't warp on you or bend. But if you don't.
Yeah, the small ones, I wasn't thinking about the small ones. We were just using the drill earlier to drill holes in the layout for the wiring, and I was thinking much sturdier stock. I was not thinking about the handheld drills. So, all right, you guys. Well, it's an hour and a half, and I think I'm going to call it.
Thank you, everybody, for watching.
Yeah, thank you for joining us tonight. It was a lot of fun, and I'm glad everybody hung around with us to get this information. This is really, really cool. I was very excited. So what's tomorrow? Tomorrow's Monday. I don't know if everybody has to work tomorrow or not, but if you do, hopefully the weather isn't going to be too hellacious outside. And if you don't, hopefully the weather isn't going to be too hellacious outside. What is Heath saying to me? Heath is saying, where did it go? Just disappears on me. We get good at using little bits if you know. It's not what you got, it's how you use what you got, right? That's all right. Okay, great show, Nisi and DB. Time to go. Yes, it is. Another great show. Thank you, Santa Fe Bob, my biggest supporter. Nice show. Work. What's work? JD, work. What's work? Yeah, retired in Texas. All right, you guys, everybody take care. And I think I said it, but in case I didn't and forgot, next week we'll be on Rick's channel, Fultz Bailey Model Railroad, and the following week we'll be on Ray's channel, which will be the 200th STS show. So looking forward to seeing everybody next week. Stay safe. And Artie, please do not go buy thongs if you're coming here, please. The United States of America pleads with you to please not buy these items.
You'll get a fine if you use them in America.
Yes, you will be fined.
Yeah, that's it.
And John Notful, if I didn't say hi to you earlier,
DBTech
being here, and he just subbed to DBTech's channel. So you're closer to 600. I think you were only like 30 or 40 away from 600 DBTech. So you're one more closer. All right, everyone. Take care. Don't do anything crazy. Bye, guys. Ending.
Okay.
See if I can.